Hello students, welcome back to today's class, and in today's class we're going to have a small quiz from the different topics that we have learned previously. Right, my name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. So what is the first question that we're going to discuss now is identify the set of like terms in the following. Like terms, what do you mean by like terms? Do you have any idea about that? Like terms. Right? So like terms are the terms which have the same variables with the same exponents. Same variables with the same exponents. Here it's a x and y. No, that is not the correct answer. Okay, here we have x and y. Right? So those are not like terms. 2x square and x power 1. No, these are nothing. So 5x plus 8x is 13x and x. 5x plus 8x is 13x and then we have x, right? So 13x and x, you can see in both the terms the variable is same to the power itself. X power 1, x power 13, x power 1 and x power 1 both are same, right? So let's move forward. Find the sum of difference between 5x square minus 15xy plus 20y square and 10y square minus 2xy minus 3x square and the difference of 6x square plus 8xy minus y square and minus 20xy minus 2y square minus x square. So just for reading it took so much of time, right? But don't worry. It's as simple as a normal subtraction addition, but you need to understand the question. Which numbers you need to add, which numbers you need to subtract. Okay, there are a lot of terms. There are completely 4 different expressions. There are total 4 different expressions, right? 5x square minus 15xy. 5x square minus 15xy. Let me erase that once. Right. So find the sum of. So we need to find the sum of. That's okay. We'll come back. Difference between these two numbers. That is 5x square minus 15xy plus 20y square. 5x square minus 15xy plus 20y square and so subtract this one from 10y square minus 2xy minus 3x square. 10y square minus 2xy minus 3x square. Okay, so that will give you 5x square minus 15xy plus 20y square minus 10y square plus 2xy plus 3x square. Right? So 5x square plus 3x square. 5 plus 3 is 8. 5 plus 3 is 8x square. Minus 15xy and plus 2xy will give you minus 13xy plus 20y square minus 10y square becomes a plus 10y square. 8x square minus 13xy plus a 10y square. Right? And the difference between these two numbers. This is the first thing we are going to discuss, and the difference of these two, so that will give you 6x square plus 8xy minus y square minus 20xy minus 2y square minus x square. So how can you write this one? 6x square plus 8xy minus y square plus 20xy plus 2y square and plus x square plus 2y square plus 2y square plus x square. Okay, so 6x square plus x square will give you 7x square. Okay, and plus 8xy plus 20xy becomes plus 28xy and minus y square plus 2y square will give you plus y square. 7x square plus 28xy plus y square, and this is 8x square minus 13xy plus 10y square. Now the question is find the sum of. So please try to quickly do what is the sum of these two numbers. Sum of these two, I'm sorry, 8 plus 7. 8 plus 7 is 15x square. 8x square plus 7x square will give you 15x square. Where is that? 15x square. 28xy minus 13. 28 minus 13 is 15xy. Plus 15xy and plus y square plus 10y square becomes a plus 11y square. Plus y square plus 10y square will give you plus 11y square. So that will give you the option B. 15x square plus 15xy plus 11y square. Okay, so moving forward for the next question, 196 square is not equal to 196 square is not equal to, right? So there you can see that 190 plus 6 is 196 whole square. That's correct. That is correct. 200 minus 4, that is again equal to 196 whole square. That is also same, 196 whole square. Next one, 200 square minus 4 square, it's like a square minus b square. 200 square minus 4 square, we have like a square minus b square, which is equal to a plus b into a minus b. A plus b into a minus b. So 200 square minus 4 square is equal to 200 plus 4 into 200 minus 4. 200 plus 4 is 204. 200 minus 4 is 196, but still we don't want this number, we need 196 whole square. So this is not the correct answer. This is not the correct answer. What about the last one? A square plus b square minus 2ab. Maybe let me check that. 200 square plus 4 square minus 2ab. So is that equal to 1600? 4 to the 8, 8 to the 16, 1600. A square plus b square minus 2ab. So that will give you 200 minus 4 whole square. 200 minus 4 whole square. 200 minus 4 is 196, and that will give you 196 square. That will give you 196 square. Okay, so that is how you can try to do that using all the different options, all the different methods. This is one way of representation. 196 you can write with 190 plus 6, or you can write 200 minus 4 a minus b whole square, or you can write the same expansion of this one, 200 square plus 4 square minus 1600, and the leftover number a square minus b square you can write in terms of a plus b to a minus b, which is not correct here. So that itself will be the correct answer. Clear? The next one. Using identities, 2 by 3 times of a plus 3 by 4 times of b whole square can be written as a plus b whole square. Using identities, a plus b whole square can be written as. Can you please tell me that? Can you please help me with that? Yes, very good, very good. Please tell me. So the basic thing is a plus b whole square. A plus b whole square is equal to a square plus b square plus 2ab. A square plus b square plus 2ab, correct? So now 2 by 3 times of a plus 3 by 4 times of b whole square. So now if you want to expand, you need to apply that formula. A square 2 by 3 a whole square plus b square 3 by 4 b whole square plus 2 into 2 by 3 times of a into 3 by 4 times of b into 3 by 4 times of b. So 2 square is 4, 3 square is 9, 4 by 9 into a square plus 3 square is 9, b square by 4 square is 16, 9b square by 16 plus 2 2s are 4 by 3 times of a into 3 by 4 times of b. 4 and 4 gets cancelled, 3 and 3 gets cancelled, right? So that will give you 4 by 9 times of a square plus 9b square by 16 plus ab. Right? So using identities, this can also be written as, so kindly check which option matches to that answer. 4 by 9 a square, okay, 4 by 9 a square, 4 by 9 a square plus 9b square by 16, 9b square by 16, okay, plus ab, do we have that? Plus ab, why, from where we got ab? 2 by 3 into a into 3 by 4 into b, so that will give you plus ab, you all got cancelled, right? So 4 by 9 a square plus 9 by 16 b square plus a plus b whole square plus 2 into a into b, so that will give you ab. Right, it should be ab only. So plus ab, so there is some printing mistake somewhere. 4 by 9 a square plus 9 by 16 b square, and then we'll be having plus ab. Okay, so you'll be having plus ab. Right. Okay. So moving forward to the next question. If 30 dozen X costs rupees 300, sorry, find the cost of 66X. Right, once again, if 30 dozen X costs rupees 300, find the cost of 66X. 30 dozen X costs 300. What is dozen? Dozen is 12. 13 into 12 is equal to 300 rupees. Okay, so we cannot write like this. This mathematically not correct. Let me erase that properly and write it again. 30 dozen X. Okay, so 30 into 12 once again. 30 into 12 is equal to 300. Okay, it's not equal to, it's equal to 300 rupees. Find the cost of 66X. So now 30 into 12 is 3 into 12 is 36. 360X costs 300 rupees. 360X costs 300 rupees. So now we need to find the cost of 66X. So for 66X, how much money you need to spend? Okay. So let's try to cross multiply. 360 into some X. 360 into X is equal to 300 into 66. 300 into 66. Okay. So 0 and 0 gets cancelled. 36 into X is equal to 30 into 66. So can we cancel with 6 somewhere? 36 is actually 6 into 6, correct? 6 into 6 into X is equal to 36 into 5 into 66 is 6 into 11. 66 is 6 into 11. So 6 and 6 gets cancelled, 6 and 6 gets cancelled, so X is equal to 5 into 11 is equal to 55. X is equal to 5 into 11, which is 55. So that is option A matches to the correct answer. Clear? Okay. So please copy that quickly. Let's move for the next question. Which of the following is false? X1 by y1 is equal to x2 by y2 is equal to k. K is a constant of proportion. X1 by y1 is equal to x2 by y2 is equal to k. And we say k is constant of proportionality. X2 by x1 is equal to y1 by y2 is equal to k. K is again constant of proportionality. And we need to talk about both A and B also. So the first one, when you try to multiply, you can also tell in that way. X1 y2, if you cross multiply, x1 y2 is equal to x2 y1. Or if you want to bring this x2 here, we'll get x1 by x2 is equal to, send this y1 here, x1 by x2 is equal to y1 by y2 is equal to k. x1 by x2 is equal to y1 by y2 is equal to k. Okay. What about the next one? x1 y2 or x1 by x2. x1 by x2 is equal to y1 by y2. Again the same thing. x1 by x2 is equal to y1 by y2 is equal to k. So there is small difference between these two. So refer to your textbooks or the guide wherever you have and try to understand the difference between constant of proportion and constant of proportionality. Where do we use this and where do we use this one? So once you get that notes, you can be sure with any of the one option or the option D. So I'm leaving that task for you. So please try to rectify which is the actual format to write those. Okay. Next one. 10 workers finished a job in 5 days. Okay. So 10 workers finished a job in 5 days. So per day, per person is doing 1 by 50th the work. How many days does 25 workers need? Okay. 10 workers finished a job in 5 days. So 10 into 5 days. 10 into 5 days total. 10 workers finished a job in 5 days. That is equal to total 50 hours, you can say. Total 50 man hours. Okay. How many days does 25 workers need? So per day I can say, per day it will be taking 1 by 50th of the work. Per day it is around 1 by 50th of the work. How many days does 25 workers need? So 25 workers 1 by 50 into 25. So 25 ones and 25 twos. So I'm getting a 1 by 2 as answer. 10 workers finish a job in 5 days. How many days does 25 workers need? Okay, so 50. There should be 2, right? I think I have done some mistake. Okay, see here. So we have total 50 hours of work. Let me try to write this in this way. Let me try to write how many days does 25 workers need? How many days does 25 workers need? So total 50 hours is required. So if we have 25 persons, you can see that in 2 hours. Okay, 25 ones and 25 twos, 50 hours by 2 persons, right? So that will give you 2 hours. So let's see the answers. I'm going to say not 2 hours, 2 days, right? So it is not hours. So that becomes 2 days. That will give you 2 days, right? So that is option D. Moving ahead, what is the next question we are having? The P by Q form of 3.6666 is, we have discussed that in the previous classes, right? So once again, let's try to discuss that. 3.6. So let's try to take x is equal to 3.666. So what is the 10x? What is 10x is equal to? It is 366.66. And what is x equal to? So x is equal to 3.66. So now you need to subtract these two. 10x minus x is 9x is equal to 3 is 6. 6 minus 3 is 2. 6 minus 3 is 3 by 0. So what is x? X is equal to 363. X equal to 363 by 9. So can we cancel with 9? I don't think so. We can cancel that with the 363. Once again, let's try to check that total multiplication. 3.666 is 10x is equal to 366.66. Sorry, 10x is wrong. 10x we had done a mistake. So we take x is equal to 3.666. We can write 10x is equal to 36.66 and subtracting x equal to 3.66. So let's try to see that. So now you can subtract 10x minus x is 9x is equal to 33. 3.6 is 33.00. So x is equal to 33 by 9. X is equal to 33 by 9. Okay, so which option is that? So option C matches to the correct answer, 33 by 9. Alright, so the next one, the decimal form of 5544 by 33 up to 2 decimals is. So the first one, as soon as you can see, that I think I can divide that with 11. 33 is 11 into 3. Let me divide 11 and 5544. 11 5s are 55. 0 44. 11 5s are 55. 0 44. Okay, so as you're removing all this, you need to keep 0 here. And then 11 4s are 44. The 11 4s are 44. That is not the thing. Okay, 11 4s are 44. So here what to do? 5544 by 33 up to 2 decimals. With 11, it is 504. 504 by 33, you can write as 11 into 3. Okay, with 11 I am dividing, so I left with 3. 504. So 3 ones and 3 504s. 3 1s, so 3 ones are 3. 1 0, 3 3s are 9. 1 4. So we cannot cancel that, right? 14. So now 3 5s, no 3 4s. 4 3s are 12. So that will give you 2 and then 0, 3 6, 20 and 0 and 18 and 2 and it again continues 134.66. 134. Once again, let's try to cross check that. There may be some mistake somewhere. Let me do it first from the first. The decimal form of 5544 by 33. 5543, 11 5544. 11 5s are 55. 0 4 4. 11 zeros, right? And 11 4s. 11 4s is 44. Let me check that. 504 into 11. So 4 0 5 ones are 5 and this is also 504. That will give you 5544. That will give you 5544, right? So 5545 is 504 into 11 and 33 is 3 into 11. And 33 is 3 into 11, right? So 504, 3 ones. Let me write that. 3 and 504. 3 ones, 3. 2, 0. So we'll get 3 6 are 18. 2 and 4. So 3 8s are 24. 3 8s is 24. So then you'll get the answer as 168. 3 8s 24. You'll get the answer as 168. Exactly. Although you have some decimal places, your answer is 168 exactly. Okay. So one more question. A number of the form P by Q is said to be rational number if P by Q is rational number if whether they are natural numbers, rational numbers, integers, whatever it is. P and Q are rational numbers and Q not equal to 0. P and Q are natural numbers, P and Q are integers, P and Q are non-zero integers, and Q is not equal to 0, right? P and Q are integers and Q not equal to 0. Last one, P and Q are non-zero integers and Q not equal to 0, right? So P can be 0. P can be 0. P and Q are integers. Integers means again, it is defined Q not equal to 0. So P and Q can be any integers and Q is not equal to 0. That is option C. Okay. So I hope you understood all these quiz questions. In the coming class, we're going to discuss more basic and advanced level of applications, and we're going to cover that in the next classes, right? Thank you so much, students. Stay tuned to get the next lecture. Thank you.
Hello everyone. So now we'll be discussing about electroscope. Electroscope is a device that will help us in identifying the charge. Okay, so that's what we'll be learning about. My name is Shashan Reddy. I'm a graduate from IIT Dhanbad. Let's go into the class. So first is this, what is an electroscope? It's very simple. It is a device, a special device used to find whether a body is charged or not. That's one use. The other use will be to find the nature of charge on a charged body. One, we'll find out whether this body is charged or not. But if a body is charged, it can be negatively charged or it can be positively charged. That also can be found out using the second case. That is, find the nature of charge. Okay, so how it works and all, what all do we need to make an electroscope? We'll look into that. So first is the apparatus. What do we need to make an electroscope? Right? So first of all, we need a glass case. Right? You can see the image here, this is the glass case. Okay? Glass case. The bottle, you can think of it as a glass bottle. Then you need a brass rod. Why brass? You can take any conducting rod, that's fine. But you need a conducting rod. Right, so this here is the brass rod. So this rod from here to here, that is the brass rod. Then we need a brass disc. Again at the top we'll make a small disc. You can make a coil also, disc or a coil, but it should be conducting. That is the reason why I'm saying brass disc, a conducting disc. Then aluminium foils or gold leaves. Aluminium foils are cheap. You can go with that. But if you have too much of gold, you can also make gold leaves, because gold is also a good conductor. You can also go with gold leaves. It's up to you. We call them as gold leaf electroscope because it's gold. But again, you can also use what? Aluminium foil. That's fine. You can even use paper also. The gold leaves are here. These are the gold leaves. How many? 2. This is the one, this is one leaf, this is the second leaf. So we need 2 gold leaves. They'll have a hole at the top. Here there will be a hole in which they will be inserted like a hook. And then you need an insulator plug. Insulator plug here, that is the insulator plug, which does not allow charges to flow away. Understood? So these are some things that we need to make a proper electroscope, and all of them can be found at our home, and in fact this device can be made by ourselves at home. You can find a glass case or a glass bottle, you can find a conducting rod, a conducting disc, You can find aluminum foils. You can also find an insulator plug. You can make use of a cork. You can make use of a wooden plug. You can make use of a thermocol. All of them are insulators. So you can actually do this at home. Okay, good. Let's continue. So let's see how it works. Okay, so let's say here this is the rod. And we have to test whether that rod is charged or not. So two cases are given to us. If the rod is uncharged, you have to focus on the leaves. The leaves are here. The leaves are just hanging, nothing. The leaves are just hanging. They are doing nothing when they are uncharged, when the body is uncharged. But when the body is charged, you can see the leaves are repelling each other. They are going away, they are repelling each other. So if the leaves divert, if they repel each other, that means the body is charged. But how? And how does it work? I'll give a simple explanation to you, don't worry. So here, let me draw a simple figure. We'll have a coil, or you can say a disc. This is the rod, and here you have the leaves. Okay. Let's say these are the leaves. They're normal. They're just hanging here. Nothing is happening. This is the proper setup. Obviously, we'll have the glass jar and all. I'm not showing all of it. The coil or the metal disc, the rod, the conducting rod, and obviously the aluminum leaves. Simple case. Now, when you touch it with a rod, let's say the rod is charged. The rod is positively charged, and when you touch, because of charging by conduction, the charges flow onto what? Onto the coil or onto the disc. Then from there, they will flow onto the rod. All of them are conductors. And from the rod, they will flow into what? They will flow into the leaves. So everything is a conductor. Why? Because charges should flow from the metal disc at the top to the leaves. From the metal disc at the top to the leaves, that is the reason why we take all of them to be conductor. And when both the leaves are positive, see here, both the leaves get the same charge. And when they are of same charge, what will happen? Will they attract or will they repel? They will repel each other. That is the reason why this happens. The leaves repel each other when a body is charged. Or else if I say, just a minute, the bodies repel each other when it is charged. Right? Because they also get positive. Simple. But let's take another case. I mean, when the body is uncharged. If the body is uncharged, what happens? Nothing happens. That is, if I say this is the coil or the disc, the rod, and you have the leaves as well. The leaves. They are not repelling, they are just placed normally. And if the body is uncharged, if the body is neutral, if the rod that you touch to the coil is neutral, has no charge, then what happens? Nothing happens. No charge flows. The leaves will remain neutral. So they'll just be hanging down. No repulsion, nothing. No repulsion, nothing. So how do you use an electroscope? It's very simple. If let's say if I want to test whether this pen is charged or not, you take the pen, touch it to the coil. You touch the coil or the disc, the metal disc at the top with the pen. If it is charged, the leaves will repel. If it is uncharged, the leaves will remain there itself. Understood? Two cases. This is the case where the body is charged. This is the case where the body is uncharged. Understood? Clear, right? Very simple. Yes, good. So charged rod and uncharged rod. The same image was shown. Right, the same image is shown here itself, here also. Uncharged body, they'll remain there itself. Charged body, they repel each other. Good? Wonderful. So here, what are we doing now? We are finding whether an object is charged or not. We will not get to know whether it is negative or positive. Doesn't matter. See here, why it doesn't matter? Because here if the rod is negative, the leaves become negatively charged. Still they repel. If the rod is positively charged, the leaves become positively charged. They will still repel. So whether it is positively charged, whether it is negatively charged, doesn't matter, the leaves repel. So we cannot exactly say which charge it is only from this. But what we can say is whether a body or whether the object is charged or not. Whether the object is charged or not. So if the metal foils in the electroscope diverge or repel each other when a body is brought in contact with the disc, the body is charged. Yes, we learned about the condition. Good. Please take this point down. Everyone. Finding whether an object is charged or not using an electroscope. If the metal foils, the aluminum foils, if they repel each other, that means the body is charged or else the body is not charged. Done? Okay, good. Next, the same thing, we'll just show the method to do. So when a charged body is touched to the metal disc, the same case we are discussing, charges flow from the charged body to the metal disc and also to the two metal foils we discussed. Positive charges flow onto the disc, onto the rod, right, onto the rod and then onto the leaves, That's what happens. The two metal foils acquire the same charge, they get the same charge and hence they repel each other. Simple, very simple and basic explanation. Understood? Here's the same points that we have discussed. Okay. So let me go into a simple question here. Which charge do the two metal foils acquire if the charged body is negative? So look at the image. This is a charged body, charged rod. If it is negative initially, which charge do the two metal foils acquire? Positive or negative? What do you think is the answer? Yeah, everyone, positive or negative? What is that going to be? And the answer is? The answer is B, negative charge. Very simple. So if the rod is negative, negative charges flow onto the disc, onto the rod and onto the foils. And by which method is the charging taking place? By conduction. Charging by conduction. We are using conductors, that is the reason. Charging by conduction. Clear? Good. Next. Now we'll see how to use an electroscope to find the nature of a charged object. That is to find whether a given rod is positive or whether a given rod is negative. How do we do that? That's what this is about. Now for this there is an interesting situation. That is at the beginning itself. That's a condition. What is that condition? At the beginning itself, we have to know whether the body is or the electroscope's foils are positively charged or negatively charged. That means at the beginning itself they should be charged. So let's look into that. If the electroscope is positively charged, the metal foils will be repelling each other as shown. So at the beginning itself, we are taking a positively charged electroscope. The beginning itself, we are taking what? Positively charged. Okay, now see what happens. Let me show that to you. Let me give the explanation. Okay, these are the two foils. Let's say they're already charged. They're already positive. I'm saying that both of them have two positive charges. This has two, this has two. 2 is just a very small number, but only for the sake of explanation. Now when I touch the electroscope with a negatively charged body. Let's see what happens. Just a minute. It has 2 positive. And we are touching the body with a negatively charged rod. So negative charges flow onto the disc, onto the rod. Now, the negative charges try to flow into the leaves, the foils. But the foils are already positive. The foils are already positive. So, for example's sake, if I add, let's say there are already 10 positive, then if I add 2 negative to it, what happens? Plus 10 minus 2, it becomes plus 8. That means the total positive charge is decreasing. The total positive charge is decreasing. So what happens here is, when the negative charges flow into it, what happens is, it will still be positive, but these positive charges will decrease. So if the number of charges decrease, if the amount of charges decrease, what will happen? The leaves will still be repelling each other, but they will come bit close. They will come bit close. Understood? Yes. So here, if I know that our electroscope is initially positive, this is known, initial case. This is known, initial case. So if I know that initially they are positive, and if then initially they are positive, there is some repulsion, then I am touching a rod. Sorry. Then I am touching a rod to the metal foil. The leaves are coming together. So I can say, if they are coming together, it should be negative. Why? Because if it was positive, let's see what happens. If it had been positive, positive charges flow, right? If it had been positive, there are already positive charges, more positive charges are coming. There are already positive charges, more positive charges are coming. That means if I take the same example, plus 10 was already there. If I adding 2 more, it becomes 12. So the number of positive charges increases. So then in that case, what happens to repulsion? Repulsion increases. Repulsion increases. They repel more in that case. Because the positive charges increase, they repel more. So here, I can say in this case, they repel less in this case, and they repel more in this case. So depending on how much they repel, we can say whether it is negatively charged or whether it is positively charged. Okay, I'll again explain. Start imagining this. Initially the leaves are like this. Yeah, I'll again explain. Look at this. Let's say these are the 2 leaves. Initially both of them are positive. Both of them are positive, like this, right? Okay. Now when you touch a negative rod, they become less positive. That means they come closer. They are still repelling, but they are coming closer. So if they come closer, if they repel less, what does that mean? That means it is of opposite charged. So here initially it was positive, opposite will mean negative. But if they repel more, initially like this, if they repel more, they are getting more of the same charge. That means initially it was positive, the rod touching will also be positive, more of the same charge. You can see a negatively charged rod and positively charged rod. So that's how we decide. There is a small initial condition. Then what is the initial condition? Initially we have to know. Initially we have to know that the electroscope is charged. Whether it is positive or negative, doesn't matter, but we have to know that it is positive or negative. But we have to know it. If it is positive, we have to know it is positive. If it is negative, we have to know it is negative. Okay. So our case here is, where was it? Just a minute. Yeah. So our case here is we took a positively charged electroscope. We took what? A positively charged electroscope at the beginning. We can also take a negatively charged electroscope at the beginning. We'll also go into that case. So positively charged electroscope. I hope you understood. We'll go into the points. Right. So here, when a positively charged rod is brought in contact with the disc of the electroscope, the metal foils are repelled further. The metal foils are repelled further. Right? When a positively charged, I told you, right? Same, the leaves are positively charged. The same charged rod is brought. It becomes more positive, there will be more repulsion. Is this clear? Good. This is because the metal foils acquire more charge of the same type and hence repel each other more. That is the reason. Okay? Good. Then, another case, that is when a negatively charged rod, as shown in the figure, is brought in contact with the disc of the electroscope. What happens? The opposite charged rod is brought in contact. What happens? The leaves come together. The leaves come together. This is because the metal foils acquire the charge of the opposite nature. And the overall charge, total charge decreases and repulsion decreases. And repulsion decreases. Okay? Good. Then let's continue. We have a very simple question with us. What is the question? If a positively charged rod is brought in contact with a metal disc of a negatively charged electroscope. So this is the initial case. Initially you can see the foils, you can look at the foils, they are negatively charged. What is the question here? A positively charged rod is brought in contact with the metal disc of a negatively charged electroscope. Start imagining. How would the metal foils of the electroscope behave? I'll give you some time, I'll give you 30 seconds to think about it. Write down the answer also. Here we are using a negatively charged electroscope, so think what's happening. How would the metal foils behave? Five seconds more. 3, 2, 1, and the time is up. So let's try understanding it using an image. And it's always better to draw diagrams. Always, wherever possible. Because diagrams help you in imagining things, understanding things better. Okay? So here, this is the rod. So if a positively charged rod, so charged rod, the rod is positive. Positively charged rod. And after that, let's look at the image. Positive charges flow. Already the leaves are negative. If you are adding positive to it, it becomes less negative. You can take an example if you want. You can say, already minus 10 were there. I am adding plus 3 to it. What will it become? It will become minus 7. So if you add positive charges to it, it will become less negative. Right? Less negative. So that's what happens. If it becomes less negative, they come closer. They repel less. They will be repelling each other, but they will be repelling less. That's what happens. Okay, you can say the foils come closer, but they still keep repelling each other. Come closer, but still repel each other. That's what happens in this case. Okay, so you can use a positively charged electroscope, negatively charged electroscope, doesn't matter. Good? Okay. Next. So this is the case of negatively charged. I've shown the images to you, very simple cases, you can go through them. Finding the nature of a charged object using a negatively charged, not positively here, we are using a negatively charged electroscope. Okay, so this is the initial case. So you can clearly see that initially the foils, the leaves are negatively charged. So if you touch it with a negatively charged rod, negative charge increases, they repel more. But if you touch it with a positively charged rod, negative charge decreases, they come closer. And compare with the initial case, they come closer, here they go far away. Understood? Okay, wonderful. Just a minute, it is what? A negatively charged rod, charged electroscope. Okay, is this clear everyone? Good. And you can refer to this link. It's an interesting link here. In this link it is discussed how to make an electroscope at home. Okay, you can watch it, and I advise you, please do make an electroscope. It's very simple, you can actually make it at your home, right? Nothing expensive, nothing much extra is required. So please do try this at home. Okay, this is the link. Chalo. Let's go into a few questions then, few questions based on electroscope itself as well as on the methods of charging. The first question is here, in which of the following methods of charging is a charged body not touched? A, B and C. By conduction, by induction or by rubbing. In which of the following methods of charging is a charged body not touched? A, B, C. What do you think? Which method? And the answer would be what? The answer is by induction. In conduction, two bodies should be touched. In rubbing, they are touched and they are rubbed. But in induction, they are far away. That's what is important. Option B. They do not touch each other. Okay. Next. Which of the following factors determine the divergence of the leaves? How much the leaves diverge? What determines them? What controls them? Amount of current flowing, amount of charge, nature of the leaves, nature of the disc. What do you think? A, B, C and D. Which is the correct answer, everyone? Which of the following factors determines the divergence of the leaves? A, B, C and D. The correct answer is B. Amount of charge. More the charge, more the repulsion, more the divergence. Simple, right? More the charge, more the divergence, more the repulsion. Clear? Option B, amount of charge. Next, which mode is used for charging the electroscope? Charging by conduction, by convection, by radiation or none of this? Which mode is used for charging the electroscope? Interesting names. But which one? Which one do we use? We use conduction. In an electroscope, you touch the rod to the metal disc. That's it. You don't rub them. No. Right? You touch it. And by only touching, the charges are transferred. The charges flow. That means it is charging by conduction. We discussed that. Right? Good. Next. What happens to the leaves of electroscope if the body is either positively or negatively charged? Remains unchanged. The leaves remain unchanged. The leaves diverge, they converge, or none of them. So in this case, let's say initially the electroscope is uncharged. It's not mentioned here, but we have to go with that condition. Initially the electroscope is uncharged. Initially the electroscope is uncharged. In that case, what happens to the leaves? That is, you take an uncharged electroscope, then you are touching it with a body which is negative or positively charged. Then what happens? What happens to the leaves? What happens to the leaves? If you touch the electroscope, the disc of the electroscope with a positively or negatively charged object, the leaves diverge. What happens to them? The leaves diverge away, they repel, yes or no? That's what happens. Okay, good. Next, what will be the total charge on the aluminium rod if the aluminium rod is charged by the plastic rod through electrostatic induction? So everyone, this is an interesting question. What you have to do is you have to imagine they are using electrostatic induction or charging by induction. So let's say this is aluminium rod, okay, and then this is a plastic rod, aluminium rod, and then this is what? A plastic rod. Now, what will the total charge of the aluminium rod be if you are charging it using induction method? That's something which we discussed. So please answer that, everyone. What is that going to be? A, B, C and D. What will it be? What will the total charge on aluminum rod be if it is charged through induction? And the answer is 0. Why? Because let's say the plastic rod is completely positive. It could be negative also, but let's say it's completely positive. And in induction, what happens? In induction, what happens is opposite charge comes on the near end. It is positive. So opposite to positive, unlike charge, positive and then negative. And like charges on the opposite end. But is any charge entering the aluminium rod from outside? Is any charge entering the aluminium rod from outside? No. What's happening is redistribution of charges. Whatever is there, they are getting distributed among themselves. Negative is going towards right, positive is coming towards left. In that case, if 4 negative charges go to right, 4 positive charges will go to left. So here, according to this diagram, plus 4 and minus 4. So when you add them for total charge, it will be 0. It will be 0. Interesting question, right? That's something which had been discussed already. Okay. So that's it, everyone. I learned about electroscope, right? And I also learned about charging methods. Okay, so please do practice them and go through the video and try making an electroscope yourself. Okay, so thank you. Thanks a lot.